Day 11, the book I'm reading is Reader Come Home by Marianne Wolf, page 24. Ring of Vision. After all this preliminary directing of our attention, something astonishing happens. The action we have been waiting for begins. Now moving rapidly out of the retinas are what appear to be two troops of cyclists for each eye, made up of brightly clad actors on huge unicycles. These troops are about to ride their cycles across the highest and longest of the wire that crisscross the entire length of the brain from the retinas in the eyes to the farthest point in the most posterior region of the brain, the occipital lobes. The troops in each eye begin together, but they quickly divide up at X-shaped intersection called the optic chiasm, which approximately enough looks like a junction of railroad tracks. At this juncture, the four sets of troops separate, which one set of the cyclist for each eye going on opposite path through multiple layers of the brain to reach the visual areas in the block of both hemispheres. The way they are organized means that each eye sends one group of its cyclists to each hemisphere. It is a masterful design with great evolutionary advantages. Consider, even with only one eye, we have two hemispheres providing us with essential vision information. The four groups of cyclists must make several stops along the way, but they seem undeterred as they carry their information at lightning speed. Within 50 milliseconds, they all arrive with their messages at one very specific area in the occipital lobes called the visual striate cortex, which gets its name from the stripes created by its 6 layers of alternating white and gray matter. After their arrival in the 4th layer of this cortical region, the cyclists fan out. Suddenly, the whole of the ring of vision in the occipital lobes is overhauled with activity. The information from the high wire cyclists is rapidly transferred to the clusters of tiny orb-like creatures that look vaguely, like little eyes with arms and feet. One group of these industrious orbs identifies the cyclist's message as a set of letters, and immediately passes that information over to the neighboring orb-like creatures in deeper region of the cortex that signal that they are real, permissible letters. Another group quickly examine the features that make up the letters, e.g. lines, circles, and diagonals, and identifies them as the well-known English letters TRACKS. It would seem almost immediately upon the second group's recognition of the letters in the world that multiple acts are performed by other teams of specialized neurons that burst into action. Some orbs perform only on single letters, while others respond to the letter patterns found in words, such as the ACK and TR in tracks. Others identify the most commonly used meaningful parts of the word called morphemes, easy prefix and suffix, such as plural s in our words. It becomes clear that each working group in this ring has its own territorial domain and works quickly and skillfully on just those highly specific bits of visual information. We can't help but notice that some groups of orbs appear placidly uninterested, or at least underemployed, with little activation upon seeing our words. Some of them identify only the most frequently seen whole words, such as stop, and words often called sight words that need no further analysis by other visual neurons. Others are obviously dedicated to other visual features. Okay, I guess I should stop here. So that's it for today. This is Minky. Please correct me if you can. Thank you.